Large language models generate text based on probability. If a user asks for a complex calculation, an isolated LLM simply guesses the most likely next numbers. To solve this fundamental limitation, we have to bridge the gap between probabilistic guessing and exact, deterministic precision. We do this by giving the LLM access to tools. A tool is an external executable capability that allows the AI to perform specific operations outside of its own predictive model. We are going to build a custom AI tool pipeline from scratch in Python, capable of taking natural language queries, routing them to the correct tool, and safely executing the result. Open up a Python code editor. We will construct this architecture step by step. Integrating external capabilities allows the model to execute code and interface directly with live data. Step 1 is defining the actual tools. Write two basic Python functions, a math calculator using Python's built-in eval command, and a mock SQL data retriever that returns a simple string. For the AI to leverage these functions, it needs a standardized way to look them up. We solve this by building a tool registry. Create a dictionary registry mapping text strings, like Python or SQL, directly to your functions. Next, we write the router. A simple function checks the query for keywords. Using an if-else statement, if the query contains calculate, it dynamically routes to the Python tool. To ensure this logic works consistently, you must standardize the input. Add a line converting the user's query to lowercase immediately. Without this, a capitalized calculate bypasses your router entirely and breaks the system. A central registry paired with a keyword router establishes a clear, structured decision path for the AI to follow. To execute the selected tool, parse the user's query and strip away the routing keyword. If the input is calculate 25 plus 17, replace the word calculate with a blank space, so only the exact math expression remains. Run the script. Your terminal processes the extracted expression and prints the exact deterministic mathematical result. Stop here. Deploying this exact code into a production environment would be a fatal mistake. The vulnerability lies in our use of eval. This function executes whatever string you pass into it as raw code. Running unverified user input through eval creates a massive code injection vulnerability. A user could write a prompt asking the AI to calculate, an import command that connects to the host operating system. The AI would execute the command, deleting critical files instead of doing math. A functional AI pipeline is a liability if the execution layer lacks protection against malicious manipulation. We remediate this by rewriting the Python math tool. Delete the eval function completely. Replace it with a secure parsing module like Python's AST library. By mapping specific syntax trees to operators, you strictly allow basic mathematics and completely lock out system-level commands. Code-level validation is necessary, but production systems require physical separation. We achieve this through sandboxing, placing the execution layer inside an isolated runtime. By routing the execution to a disposable Docker container, any malicious code that slips through only damages a temporary environment, leaving the host server completely untouched. Robust code parsing and strict execution boundaries ensure autonomous AI agents can operate safely. Your end-to-end pipeline is now secure. You have a centralized registry storing your capabilities, a router directing the traffic, and secured parsing logic to handle the execution. When you pass a complex query through this architecture, the system safely bypasses the generative model's guesswork and produces a guaranteed deterministic answer. The next step in scaling this architecture is swapping out the hard-coded keyword router for a semantic API call, allowing the language model itself to reason about which tool to select. Establishing these execution layers allows models to perform actions, from updating databases to processing hardware commands, moving functionality beyond simple text generation.